Hello and welcome back to Master Engineer. In this tutorial, we have a beam with two roller supports at point A and point B. The beam carries multiple point loads as shown in this figure. We need to find the support reactions and draw bending moment diagram and shear force diagram. We start the solution by drawing the free body diagram. Since our support are roller support, we only have one reaction. At point A, we have VA. At point B, we have VB. And we put back all the point loads on the top, acting downward. Then we'll move on to find VB. To find VB, we take moment about A. We use the equation of equilibrium. The sum of all moment at point A should be 0. We start from the left-hand side of the beam. We have this 60 kilonewton acting anti-clockwise, therefore negative, multiplied by the distance 1 meter. Then we have this 35 kilonewton acting clockwise, multiplied by the distance 1 meter. Then we have 35 kilonewton here acting clockwise again, positive, multiplied by the distance from this point to here, which is 2.5, positive 35 kilonewton acting clockwise again, the distance from here to there, which is 4 meter. Then we have VB acting anti-clockwise, negative, multiplied by the distance from here to there, 5 meter. Then we have 60 kilonewton acting clockwise, multiplied by the total distance from here to there, 6 meter, equals 0. We plug these values into the calculator, and that should give us the value for VB, positive 112.5 kilonewton. Then we move on to find VA. Similarly, we use the equation of equilibrium. The sum of all vertical forces should equal 0. We have minus 60 acting downward, positive VA acting upward, negative 35 acting downward, negative 35 kilonewton acting downward again, negative 35 kilonewton acting downward, positive VB, we found the value here, which is 112.5 kilonewton, and finally negative 60 kilonewton acting downward, equals 0. Plug all this into the calculator, we find the value of VA equal 112.5 kilonewton, the same as VB. To check our answers, we take moment about B. The sum of all moment at B should be 0. We have minus 60 acting anti-clockwise, multiplied by the distance from here to there, 6 meter. Then we come across VA acting clockwise, multiplied by the distance from here to there, 5 meter. Then we have 35 kilonewton acting anti-clockwise, multiplied by the distance from here to there, 4 meter. Again, 35 kilonewton acting anti-clockwise, multiplied by the distance 2.5. Negative 35 kilonewton acting anti-clockwise, multiplied by the distance from here to there, 1 meter. Then we have 60 kilonewton acting clockwise, multiplied by the distance 1 meter, equals 0. We put the value of VA here, 112.5. If we plug all these values into the calculator, it should give us 0. We move on to draw the shear force diagram. It will make life much easier if you have the free body diagram here. We have X and Y axis. We start from 0. Then we could see 60 kilonewton from the free body diagram acting downward, which is minus. We draw a straight line all the way down to minus 60. The shear force is constant from this point to this point, which is from here to there, until we come across the support reaction at point A, which is 112.5 kilonewton. So we have minus 60 here. As we said, this is constant. Then we come across the 112.5 kilonewton acting upward, which is positive. That will give us 52.5. So from this point, we draw a straight line all the way to roughly here, 52.5. Again, since we don't have any other forces acting within this distance, therefore the shear force will be constant again. Then at this point, we come across this 35 kilonewton acting downward. So we have 52.5 and 35 kilonewton acting downward, which is negative. That will give us 17.5 kilonewton. So from this point, we come down to 17.5, roughly here. Again, a constant shear force all the way to this point. We come across another 35 kilonewton acting downward, which is negative, minus this 35 kilonewton acting downward. That will give us minus 17.5 kilonewton. So we draw a straight line all the way to 17.5. Similarly, the shear force will be constant all the way to this point until we come across the last 35 kilonewton, minus 17.5 at this point, and minus 35. That will give us minus 52.5. We draw a straight line all the way down to minus 52.5. Constant shear force again until we come across the support reaction at point B, which is 112.5 kilonewton. At this point, we have minus 52.5 and positive 112.5 equals 60 kilonewton. We draw a straight line all the way up to positive 60. Since we don't have any forces acting within this distance, so the shear force is constant again, until finally we come across negative 60 kilonewton acting downward, so positive 60 kilonewton minus 60 kilonewton, a straight line all the way down to 0. Next, we move on to draw the bending moment diagram. Draw straight line like this. Each line represents the point load and the reactions. We start from the left-hand side of the beam from 0. Please note, since we are calculating bending moment, the unit will be different. If we look at the shear force diagram, we have minus 60 here. So we draw a straight line from 0 to minus 60 here. And the way we found this minus 60 is force multiplied by the distance, minus 60 multiplied by the distance, which is 1 meter from here to there. So we have minus 60 kilonewton meter. Then at this point, we have 52.5 positive, multiplied by the distance, which is 1 meter again. So minus 60 positive 52.5 multiplied by the distance, 1 meter, equal minus 7.5 kilonewton meter. From the minus 60, we go up to minus 7.5, roughly around here. From the minus 7.5, we have 17.5 multiplied by the distance, 1.5 meter, and that's positive, equal 18.75 kilonewton meter. From positive 18.75, we have 17.5 multiplied by the distance, 1.5 meter, equal minus 7.5 kilonewton meter. So from 18.75, we draw a straight line to this point, which is minus 7.5 kilonewton meter. Next, from this point, we come across the negative 52.5 multiplied by the distance, which is 1 meter. So from minus 7.5, and we have minus 52.5 multiplied by the distance equal minus 60 kilonewton. So from negative 7.5 all the way down to negative 60. Then finally, from this point, which is minus 60, we have positive 60 multiplied by the distance 1 meter equals 0. So from negative 60 all the way to 0. So we started from 0 and we end at 0. This is the end of this tutorial. Thanks for watching. Please remember to like, share, and subscribe.